I'm Scott Friedman. I'm from the AWS Higher Ed research team. We support research in higher ed, obviously. I've been with AWS for 5 years. I'm a computer scientist, and before I joined AWS, I ran research computing at UCLA. I like to say a little school down in the beach, down in Los Angeles. So I did that for a very long time, almost 30 years. And I will save you my bad joke. So we're going to talk about AI primarily today. But before I do that, I want to talk a little bit about how AWS engages with research more generally, because I think there's some useful things for researchers to know that they often don't when I meet with them and see what people are doing. And it's worth knowing that our team exists, that we're always happy to hear from people just with questions, and it doesn't cost anything to speak to us. I always tell people, don't be shy. If you're just curious about something, or how to do something, or how much it might cost to do something, shoot us an email. You can shoot one to Jeff, who's the person who's responsible for UW, or to me, or to any of the team, and we'll get it to the right place. These are kind of the areas we focus on at a very high level on the research team. So obviously we're here to help you accelerate, some of this is kind of businessy terms, but accelerate your research, help you get your work done more efficiently, quicker, faster, cheaper, that kind of thing. Typically that revolves around providing access to resources, compute and storage resources that are beyond what you have available to you in your lab or your office or the campus. These days that typically revolves around GPUs, as you could imagine. But there are other areas as well. The cloud is all about flexible access to resources, meaning basically it's a big box of Legos that you can put together in almost any way that you want. So it's a little bit different way of thinking about solving technical and infrastructure problems than you might doing it, again, in your lab or on campus, right? Where you have to make a lot of decisions and you're going to stick with those decisions for usually a long time, which is nothing wrong with that. I used to do that too. The cloud kind of augments that with another dimension. That's the way I like to think about it, or ask people to think about it. Services beyond HPC, I mentioned when I tried this the first time, that an example of that is quantum. So we have on AWS every commercially available quantum computer available for you to use. So you can do simulations on AWS, you can do hybrid HPC and quantum with actual quantum devices. I don't think any of our friends in other companies have all of them, and we actually kind of phase them in and out. As machines kind of get older, we take them out of service, and then as new devices come online, we add them. So that's something to know, that's out there. And then lastly, one of my favorite aspects of the cloud is keeping up with, here it says innovation, but basically, if it's new, we have it. So if it's the latest AMD processor, we have those. If latest Intel, we have those. We have ARM processors. I mentioned quantum. We have our own chips. These things are happening. On the GPU front, same thing. And again, this is why people come to us for GPUs and NVIDIA stuff in particular, because the first stuff out of the factory usually ends up in one of our data centers. So there's no waiting to get access to these things. There's a little bit of waiting, but generally compared to waiting months for hardware, it can be available to you in a matter of hours or sometimes a few days. How does our group, I'm gonna just bring all of these up. I'm one of these people who does not like animated slides. Anyway, these are the areas that our group and our wider team and public sector support. We start early on. We do events like this where we come out and talk and share what we're about and how we can engage and help. Or like I said a minute ago, just project guidance. You have an idea about something, how to do something, and we're happy to just rap about, bring our experience. People like me and others who've worked at national labs. I mean, we have people of all different backgrounds and domains working at Amazon and at AWS that you can interact with. Proposals, that's a great time to interact with us, particularly if you think you might want to use cloud as part of your project. We're always happy to do POCs at your proposal stage to kind of build out a smaller version of what you're thinking on our dime, so that you can get good numbers and good architecture for putting it into your proposal. And we're always happy to give you a letter of support, or I guess it's called a letter of collaboration if you want to be lawyerly about it. But if you want that, we have those as well. Building on AWS, one of the challenges with the cloud is, like I said, a big pile of Legos, and it's like the box that's just the pieces, not the kit. And we have solutions architects and other people that can help kind of curate and guide you through putting things together. So you can stick to whatever your domain is and not have to become a cloud engineer, right? A lot of people are like, cloud's awesome, but I don't have the time to learn how to do all this stuff or the interest, frankly. We have people that can, help you do that or point you in the right direction. So there's a minimal amount for you to learn and understand. And that goes with running solutions in the cloud. And I'll talk a little bit about that later. People are worried about cost and spending and overspending and doing something that, becomes a problem. That's kind of a very common refrain that I hear all across the country. I ran into this myself at UCLA, so I'm very familiar with this concern. And again, this is why I say don't be shy, right? Rather than just try and muddle along and figure it out on your own, talk to us so you don't shoot yourself in the foot, right? And then have a bad experience. We want you to have a good experience, and we want to help you do that. So just keep that in mind. And then the last part is, I have some other slides that we'll get into these points here in a second, but we have tons of learning materials. We have tons of code, open source code, way more than people, I think of when they think of Amazon or AWS. It's almost too much in a way, but it's mostly all free. One thing related to that I always talk about, because a lot of people don't even know we have this program, which is a global data egress waiver. So a lot of times people are concerned about, well, if I put my data in the cloud, getting it out is going to cost me an arm and a leg. Normally that would be true, I will admit, but this program has been in place for a very long time, I think more than 10 years now. And the secret here is you really want to make sure that the accounts that you use for your work belong to the university, meaning the university gives you the account. Do not use your personal account, okay? A lot of us have, personal Gmail and all of that. You may also have, a Google account with UW. If you get an AWS account, you want to do things on AWS, I highly recommend that you get the university to vend you an account. It shouldn't cost anything. There may be other things you need to do or your lab needs to do, but the reason is that when we calculate that 15%, it's against the entire spend of the university, not you specifically. So if you imagine if you're going to have a little bit of egress out of your account, a little bit compared to the total spend of the university, you get a pretty high bar. And I can tell you in the, 8 or 9 years we were using AWS at UCLA, I never saw an egress charge because grades and payroll was also using AWS and they were running up a big bill. And, so that 15% high watermark was pretty high. So my little tip there is make sure that you're using a university account. The other thing is if you're using a personal account, you're not under this program either. It only applies to universities and other research organizations. So good to know. The other thing is it applies to a lot of different ways of doing egress. It's probably more detailed than any of you care about right now. But the point is that's there, and it really should not be a concern. And if it is a concern, what do? You should reach out to us and tell us what those are so we can either explain how you shouldn't really need to worry about it, or we can mitigate it in some way. Another program that not enough people know about is our open data registry. Some of our friends in the industry have copied this idea, which is fine. There are, I don't know how many petabytes of data on the open data registry at this point. It's all free. The egress is free also, unlimited free, not 15%. It's just totally, so even if you're not using AWS for anything else, which of course we want you to consider, using this data rather than having people have copies of the same thing on your storage systems, which I know happens, just yank it down from here, right? These systems are very, very fast and ridiculous bandwidth, so you shouldn't have a problem. In fact, the demo I'm going to show you later that I have actually pulls data directly from the Open Data Registry to build up its database. So this is something good to know about. There's tons of data there, and they have a big catalog, and you can look for what you want. And what I really like about it, it's too tiny for you to see sitting here in the room, but if you go to any one of these pages, there's documentation, there's metadata, there's even like examples of how to use the data, code samples, so the people who are committing this data to the program, have all of this stuff. And the last thing I want to say about this is that if you have data that you feel is broadly useful to the research community, you can put your data on here as well for free. So Amazon will host it. There's a very short form that you fill out, and the team that runs the Open Data Registry will evaluate it and talk to you. And I think I don't decide what goes on there, but I can tell you that I think the bar is not super high. I think what they really want to see is that there's a community of people out there that would benefit from the data being made available in this way. The governments use it, companies sometimes use it, foundations use it, and there's a lot of university data. There's also a kind of, the same platform can be used for sharing data in other ways. Let's say you want to share data that's gated. You can do that on here as well. That's a little bit different, but it's the same program. Yes?
Do you take databases?
I'm sorry?
Do you take databases?
They're not databases, it's just the data. Yeah, so it's not like a SQL query kind of thing. You can pull the data out of there and do what you want with it. So that's a good question, actually.
Is it stored on S3?
It's all S3.
Cool.
Yes. So you're going to use S3 to pull it down. I think you can do that with HTTP, but using S3 is going to get much better performance. Okay. Some broader things. We have a lot of programs. You should know that Amazon, AWS is a part of Amazon. Then there's the other part that delivers packages to your door every day, which my daughter still thinks that's the part I work for, is the part that brings the packages. The broader company has something called Amazon Science. That's not exactly similar to Microsoft Research and Google and HP and all the other companies. It's similar, but we also have calls, research calls. So if you're looking for other places to find money and support, this is cash money and credits. It's not only credits. You should check into that. And then a bunch of other things for postdocs and people who want internships and all the other kinds of things that we do. There's a few things I want to drill into. One is this just came out in March, not earlier this month. This is a program called Build on Trainium. So Trainium, and I'll get into what Trainium is in a few minutes, but that is Amazon's accelerators for doing AI. They have a program, the company is backing this with, I think, $170 million, a good chunk of change, for people to do work. They're looking primarily for people that want to do novel AI type algorithms and kernels, but using the Trainium chips. And just so you're like, Trainium, who's using Trainium? Mostly Anthropic and a few other companies that begin with A are using them at a scale that will make your eyes water. So it's not something that's just some arcane thing sitting out there. These chips are probably the most used after NVIDIA's in terms of like production level AI in the world, okay? So check that out. They have calls for other things. Just like most companies, they tend to be siloed into things the company is interested in. So at Amazon, that happily is quite a wide range of topics, but it tends to float around AI, which is where this lands. Operations research, which is probably obvious on the consumer side. Robotics is a big area at Amazon, and a few others. So, but I encourage you to check that out. Two other programs that are more related to universities directly is CloudBank and Strides. Actually, UW is one of the PIs for CloudBank, along with UCSD and Berkeley. This is a program that allows you to essentially avoid the F&A rate on your NSF awards, which is often a good thing. It's less of a concern for you guys here because you don't have to pay F&A on cloud services like I did at UCLA. But this is a useful program. It comes with a lot of other support and training. You have a lot of support here anyway, but I just want to make you aware of that. And it Strides is a program the NIH supports. We'll see what happens given everything that's going on, whether that continues. Schools usually do this because they get there's a discount involved, but some schools have a better discount than what Strides offers. So it really just is it's a choice the institution usually makes. But that also has a lot of training and materials, orbiting around the program. But what I would say to you is if there's particular things you want to learn or figure out how to do, now you know you can reach out to me or to Jeff or any of the others, and we can hook you up with the same materials anyway. So you don't necessarily have to go through those programs. All right, let's get into what we actually bring to the table. So at the lowest level, we have tons of compute, as you all probably can guess. I learned that Amazon or AWS adds more hardware every day to AWS than the first day that it started, back in the day when S3 was the first service. They add more hardware every single 24 hours than the whole system, the whole AWS had at the very beginning. So the scale is crazy, which is not super relevant to any individual like any of us. If you're Netflix or a bank or whatever, that it does start to matter, that kind of thing. But what it means for researchers is there's this huge array of capabilities to choose from. And I actually find that this is sometimes overwhelming for people who are not nerds like, the nerds with the interest that I have. So many times people need some curation and some help to go, this is what I'm doing, what should I use? Just tell me, right? Just tell me the one that I should be working with. And again, honestly, the easiest way is just don't be shy and just ask, right? Or ask your local people and they can ask us if you're like, well, Scott seems really intimidating or scary, so I don't want to talk to him. I'll talk to someone here. Fine. The point is, don't spin your wheels. Just, it's not worth it, right? We can just tell you and start with this, and you're done, and you're on your way. But whatever you want, we have. It's usually bigger and faster, or bigger and faster is available. I'll just say for those of you who are more nerdy and build your own computers and all that stuff, when you buy your AMD or Intel processors, all of our processors are turbo speed all the time on all cores, and usually faster than what you can buy at Newegg or even Amazon.com. So the speed is generally 10 to 15% faster than anything you can build or buy, right? So that's another little tweak. The other thing, as I said earlier, we're constantly bringing in the new stuff. So you basically are letting Jeff Bezos worry about keeping up the technology. You're not buying something and keeping it for 5 or 6 years, and the relative speed drops, right, compared to what your peers are doing, because then they bought something 2 years after you and it's going to be faster. In the cloud, you can always stay at the leading edge. Same thing with GPUs, right? You spend $1 zillion on an H100, and NVIDIA is already onto the generation beyond coming out. If any of you were at the NVIDIA conference down in San Jose, right? They're already on the B200s now. So, that's what I want to say. That's a kind of a part of research computing using the cloud that I think a lot of people don't really consider. Or you can try different architectures, like ARM. I do everything on ARM now. My Mac is an ARM, and I thought, maybe I'll just do ARM in the cloud using what's called Graviton. Actually, the Graviton 2s and 3s are already up to the 3rd generation, are extremely fast if you do computationally intensive computing. The floating point performance is pretty ridiculous. And they're cheap, really cheap compared to what we're all used to using. All right. A little more detail on this. I guess we'll share this deck later. I'm not going, since we're way past, I'm not going to spend a lot of time on this. Just goes into a little detail on what I said. How do you consume these things? On demand, that just, you go on and go, give me a machine, and it spins it up for you, and you load an OS as part of that process and log in and on your way, right? And usually when people look up online how much it costs to use something on AWS, that's what they look at, is the on-demand price. On-demand means I want it right now, okay? That if you're smart and know how to turn things off when you're not using them, that's a totally fine way to do things. The other are savings plans. That's an investment. That's like, I know that I'm going to be using this for a year. I think the other option is 3 years. You get a pretty hefty discount for that. I think it could be up to 50 or 60% off the on-demand price. But that's really only for people that have a real steady state use, which in research, frankly, is not that often, frankly. If you have a group of people and you want to share it, then maybe it makes sense. And again, that's why you would talk to us. This is what we're thinking. Does this make sense? We're happy to, and if it's not, I'm going to tell you it's not. I go, use HIAC, right, is what I'm going to say. We have no problem saying that. I mean, we really believe it's a combination of resources, not you should just stop doing what you're doing and use the cloud. The last are Spot instances. Many people have heard of Spot. Spot was a really cool, well, it still is a cool thing. When it first came out, it was kind of like eBay, bid for machines and, or what's the other one? The travel place where you go, I'll pay $10 for a room and you get what you get. It doesn't work that way anymore. For those of you who don't know, the prices they do change, but they're pretty static over the long period. They change very slowly. So there's no gaming, there's no market anymore, right? That you can save, it says up to 90%. It can be, anywhere from 70 to 90% off. Now these are for short workloads, or if you checkpoint. If you run big things, you want to be checkpointing. You can also check and see how often nodes get yanked out from underneath different instance types. One trick I will suggest with Spot, and I could talk for a half hour about Spot, but is to use what are called instance families, because when you're looking for Spot, some things are used a lot and they'd be harder to get. But if you kind of specify a broad family of instances, it doesn't matter which one you get, because we have a lot of letters and things after the names, and it's basically the same machine, but this one has a little bit of better networking or more storage or whatever, and you don't care. That's a way to really save a lot of money and run quite a bit. And again, if you can suffer from the machine getting yanked out from under you, and you get a warning so you can save your data, then that's a real good option. And again, the SAs and other people can help you figure out how to take advantage of that if that's something you're interested in. I wouldn't recommend you sort of beating your head against the wall, spending money or time, actually more time than the money trying to get things to work. NVIDIA. I always get asked about NVIDIA. We have a great relationship with NVIDIA, and I mean that at the company level that I have nothing to do with, and then even at the level that I work. We work very closely. I work very closely with NVIDIA, the analog of our team that covers UW, the NVIDIA team that covers UW. Like, we all know each other. So if you're working with NVIDIA and you're having a problem and whatever, I think you could go to either one of us, and we talk about you when you're not there. We have all the latest stuff, right? I mean, even the B100s are coming real soon. They're already up and running internally, and I think big customers are trying them out. And again, these points at the bottom are interesting because they talk about this point I made about the technology advancing and older hardware kind of staying where, well, it's not kind of staying where it is, it does stay where it is, and that there's a gap that starts opening up. I'll just give you a quick story. At UCLA, we had a big NSF MRI award. MRI is Major Research Infrastructure Award, right? For a big GPU cluster in 2010, 11, a long time ago. 400 GPUs, K80s, right? Well, the researchers there, was mostly physicists that were using it, used it for about 3 years. As far as I know, that cluster is still there. Nobody's used the GPUs in years. Because they're completely useless at this point, right? You can buy one, and your laptop's GPU is probably more powerful than that now. So this is an example of, this divergence that happens pretty quickly in the GPU world. We actually stopped buying GPUs at UCLA for this exact reason. It's like, this is not a way to, it's very expensive to run them, which you don't see that cost. They take up relatively little space, but you can't fill racks. There's all kinds of challenges with GPUs on-prem. And the AWSs of the world to figure out how to deal with this. The point is that when there's something new, it's going to hit the cloud and hit AWS very quickly. So if you want to try the latest thing. The other question I get is, which of your zoo or alphabet soup of instance types maps to what generation of NVIDIA architecture? Those of you who do CUDA and things like that, this is useful. For the rest of you, it probably doesn't matter, but I get asked about it enough that a few of us created this slide so you can see, what maps to what. Because sometimes code needs, an Ampere system or, that or newer or whatever, and this helps you figure out what the instance types are. And if you're curious if I'm kind of making up a story about NVIDIA and AWS, this should help dispel that. So this Project SIBA, which is I think how you pronounce it, basically NVIDIA is building the biggest supercomputer ever, as far as I can tell. And I've been doing supercomputing for 30 years on AWS. This is not for you and this is not for me. This is for NVIDIA. So NVIDIA is doing their research and their chip design on this cluster that lives in AWS. So if you think you can't do your work in the cloud, I hear this all the time too. Oh, it's not as fast. Believe me, people are doing super heavy duty stuff in the cloud, super tightly coupled workloads in the cloud. Oil and gas, financial markets, drug companies, they're all in the cloud now, right? Almost none of them have data centers and do this on their own any longer, right? It just doesn't make sense. Now the economics is different for commercial companies than it is in research, but when it comes to the performance question, don't let that hold you back. And if you don't believe it, again, don't be shy and reach out and we'll give you some credits and you can try it out for yourself, right? And make your own decision. All right, purpose-built accelerators. So this is what I was talking about, build on Trainium before. We have two kinds of chips. We have Trainium and Inferentius, and I think you could probably figure out which one is for which. Much, 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 much cheaper than using GPUs, even on the training side. And these are very powerful systems. I don't think maybe I did copy it. Let's see. No, I didn't. There's a great story about Perplexity. They did a blog post on how they achieved 3.2 terabits of networking speed, tightly coupled, for the work they're doing using Trainium 2 chips, right? So, these are very high performance systems, and there's kind of two versions. There's the big one, and there's a smaller one for, probably stuff like, if I'm just experimenting with this. How do you use this? Does it use CUDA? No, it doesn't. But the layer that are kind of, it's not fair to call Neuron CUDA, but it's a SDK for these chips, has been things like PyTorch, TensorFlow, a whole bunch of libraries like that have been ported to support the Neuron SDK. So for the most part, you should be able to run most kernels that you run on, say, PyTorch without changing much. And again, if it doesn't work, that's why we have build on Trainium, and we want to know, and the engineers want to fix that and work on it. There's now Trainium 2. Actually, they announced Trainium, that's being in preview. I think says at the bottom, down here in pink or purple or whatever color it's showing up as. We also have Trainium 3, which was just announced at the end of last year. So again, it's this march of performance that's out there. HPC, kind of tightly coupled to AI a lot of times for training and other kinds or a lot of people tie them together. And I'm going to go quickly on this because I was just saying, the performance is there. There are two main ways that people do HPC on AWS. One is using batch. Batch is kind of a cloud native batch system like Slurm or PBS or one of the or UGE if you're used to that kind of thing. Parallel cluster is a more traditional kind of head node with Slurm on it, and it basically bursts into the cloud. So all you have is head node with no actual compute nodes until you submit jobs. But it works in a very similar way that you would be used to, say, using Hayek. We've been working with the Hayek team for a while now to actually implement the third way, which is bursting from your on-prem system into the cloud. So when you submit a job into a partition, a special partition that's for bursting, those resources are spun up dynamically in the cloud for you to run whatever it is you're going to run. If you're going to do, we're all here about AI today, we're going to do training or inferencing or whatever in a batch environment, this is a good way to do it. Security, I'm going to skip over that. Security is a big thing. It is for the universities anyway, and there's a lot of ability to do security on AWS. Adopting AI and machine learning in the cloud. There's a lot of tools. There's a lot of things to learn. Forget about just how fast the science and the research in AI is going. Just all the tooling and the libraries and the frameworks and the this and the that. It's like really difficult to keep up. And one of the things we've tried to do is kind of bring all of those things together in a way that makes it easier for you to kind of get your head around it, particularly if you're not an AI researcher. You're a domain scientist and you want to start incorporating AI into your work. This is some of the things that we're going to talk about here, and I think what you're going to see, or the environment you're going to use later, are a good way to get your feet wet, because all the things you need are there, and a lot of the kind of heavy lifting that you might have to do to set something up is taken care of for you, right? Kind of what we call the undifferentiated heavy lifting. But a kind of easy way to understand how we break things apart is this way. One is at the bottom, we have these kind of infrastructure level things and more low level stuff. This SageMaker, many people have heard of SageMaker. They just rebranded it SageMaker AI. That's some corporate thing. And there's some tooling inside of there that I'm going to get to in a second. I mentioned Trainium and Inferentia and GPUs, right? This is kind of access to that hardware in an environment that's, let's say, more friendly to use, or using things like Jupyter notebooks and VS Code and things like that you might be using anyway. Above that, the middle layer's Bedrock, which I'm going to show you a demo of using Bedrock in a minute. That's basically an easy way to use LLMs. That's kind of my one sentence description of what Bedrock is. Meaning there's kind of one API and you can flip out the LLMs as needed, or other, it's a little more nuanced than that. But the point is that this is a way for you to be able to use these things, which otherwise would be a huge pain to set up and keep running, right? I mean, a lot of us use, Llama and other things that are kind of tiny little models that you can do, or you can struggle to get a, pretty big model to run on a hefty workstation. There's really kind of no reason to do any of that. You can also leverage the APIs of the LLM companies directly. I have a personal project that I use Anthropic directly. But then I was like, it doesn't cost any more to use Bedrock. It's the same price. And the benefit of using something like Bedrock is I'm not sharing any of my data with Anthropic any longer. The model use is private. You're not sharing it with anyone else using Bedrock. So if you have a concern about that, right? When you're going through something like Bedrock, that's all private, right? Amazon's not going to use any of your data to train the models or retrain the models. Anthropic, in the case of Claude, is not going to use any of your data to train the models. So that's something to consider. Plus you get the flexibility and you let Amazon run everything for you. And at the top level, there's these Q, whenever you see Amazon Q, these are these very high level services that are, more prescriptive in the way that they do things. And, if you say, I just need something that translates, English to French, right? I mean, that's the kind of level that you would look at there, or do image recognition. There's a bunch of other tools at that level besides those two, but that's kind of the high level, just kind of a black box capability, which is sometimes useful. SageMaker AI. So this is what's traditionally been known as SageMaker. This is a really handy tool. It's mostly notebook based. One of the things I will say quickly about SageMaker is there is a ton of learning materials on SageMaker, a ton. So if you're just getting into AI, getting into it to a level of using it, not just, how many R's are in strawberry, that kind of thing. Starting to figure out how to use it, in a practical way. Getting onto SageMaker is a really smart move because there's a ton of stuff there, way more than any other platform, and it's organized in a more pedagogical way. So they have these things called jump starts that can kind of take you through tutorials where you kind of build on your learning that are very, very nice. And if you don't have an account that you can use, we have something called SageMaker what is it? SageMaker Studio Hub, or I forget the name of it now. There's a free version that you can use to kind of get started. But that you can get a GPU on there, but it's kind of time limited, and it's more constrained in what you can do. But if you just want to get a taste, that's a good thing to check out. But SageMaker AI now has all these other kind of capabilities attached to it. Not only can you build models from scratch, you can refine models, you can distill models, you can do all kinds of other things, right? Definitely check it out. There's other things like governance, if you care about, governance here means, you want models to do ethical AI and make sure it has guardrails around it. There's tools for doing that as well. And again, this is kind of like taking away a lot of the heavy, undifferentiated stuff that you could waste hours and hours and hours setting up or figuring out. And you pick a model or you pick a tool, and then a month later it's like, oh no, the cool tool is this one, not that one. No one's using that anymore. Many of us have been in that situation. A little more detail of the kind of, machine learning, deep learning, Gen AI for, you want to kind of understand the difference between them. A lot of tools for cleaning and labeling data. So, typically many of us are used to using like OpenRefine or tools like that to do data cleaning, which is still an awesome tool. A lot of these kind of capabilities are built into SageMaker as well. So you can, obviously we kind of having everything in one place has some benefits. SageMaker Studio is kind of a level up from that starts incorporating an IDE. I think at that level you can use VS Code if you want, not just the Jupyter notebooks. And there's more tools, and it's kind of broadening out the ecosystem, right? So if you really want to start kind of more contained, you just start with regular SageMaker, or they call it Classic. You could go out to SageMaker Studio. Looks a little bit like that. You can see you can pick VS Code, the symbol there, those brackets, or Jupyter. And then above that is this Unified Studio. So what is a Unified Studio? This is relatively new. Actually, it is new, in terms of being available publicly and just generally available. And what it's doing is kind of going out another level from even SageMaker Studio, which is bringing in bigger data management tools. So if you have a data lake or a big pile of research data, and there's other tools that we have. I think the next slide gets into some of those. You talked about SQL and having databases in front of this stuff and integrating that with Gen AI tools, or even just regular data machine learning or regular AI type of activities and building models. That can all be kind of brought together in one unified platform. Because what we were seeing is people were using this and trying to bolt things together. So the way Amazon and AWS works is we see people struggling with something. Okay, let's try and make this a little more organized. So it's taking a lot of disparate services and tools, remember the Legos, and turning it into more of a kit that you can use. That's really the way to understand where we're going with this kind of organization of this. Okay. Jump starts. So I mentioned jump starts before. There are tons and tons and tons of them, and they bring in like all the Hugging Face stuff and from all different, the open source stuff from Meta and many of the AI companies that are out there. They have stuff that goes into more detail about how to use their models and their tools and what their features are. And what the jump starts are like tutorials and demos and things, so you can start having little pieces of things to be able to explore and build your own solutions or try things out. So I highly recommend checking out the jump starts. I think that's, to me, one of the best features other than just what SageMaker is capable of doing. The other thing I'll mention about SageMaker is that, and actually this is a good slide to talk about this, is it says on the left there, fully managed training jobs. So there's ways in SageMaker to say, okay, here's my data and it's cleaned and labeled and all the rest, and now I want to develop a model. There's a way to do it where you can just let SageMaker do all the infrastructure stuff for you, right? Which, for many people, they're like, I don't, that's like a whole rabbit hole I don't want to go down. Now other people say, no, I want to tweak every knob and wire every connection up myself. And that's what these kind of hyperpod approach is. So you can go either way here. So there's the flexibility to get down and dirty with the hardware if you want, or just let the professionals, the infrastructure professionals, do it for you, and it's more of a service. Service in the sense that you don't have to worry about what's going on. There's parameters and knobs you can twist, but it's like your car, right? You don't, when you need a car, you don't go to the store and start buying parts and build your own car. You just get one and use it. This is kind of what the left is. The right is more like, I want to build my own thing, which is totally fine, and there are researchers who need to do that. But I think what I'm seeing more and more of is more and more domains start leveraging AI. They're mostly doing it on the inference side. They're not building models, for example, or they're refining models, or either distilling a big model, or they're adding their own data into it. This is probably a more practical way. And if at some point you realize you need to do something very specific, or that this doesn't cover, well then, there's always the other way as well. But I think, just getting going or getting something useful, this is probably a big time saver, right? That's another thing to consider. How much time are you saving by using some of these things rather than spinning your wheels setting stuff up? As someone who's spun his wheels for most of his career setting things up, I can tell you there's a big advantage of having some of this just done. It's like, I don't really care how this works. I just need it to do the thing I need it to do. Okay. The interesting part about this slide is actually, to me, that what I want to talk about, given our time, is the thing on the left. So when you're using SageMaker or even Bedrock, which we'll get to in a second, there's an API, and there's different ways of interacting with these services, right? As more of a service or a capability, rather than wiring it all up together. You may just have kind of synchronous responses in real time, kind of like a chat. I entered a prompt and I wait and I get the response back synchronously. Then you have kind of asynchronous responses. That might be something where you make a prompt, but then data comes back based on some, other trigger that might be out there, or combining it with some other data, right? Tell me, keep me updated on what's going on, with some sensor network or something like that. And then finally, you have kind of batch offline stuff. I need to do an analysis on, 100,000, surveys, or people filled out doctor's notes or whatever, right? That's something you don't need to sit there and type them in and wait for the response. You would just throw them at the system and let it do it when it can, probably much more cheaply. And of course, on the right is really about how you can deploy things, right? You can use containers, you can use the models directly through APIs, like I was just describing, or at the bottom, you can just roll your own, right? So it supports all of those different levels. It's also useful to talk about data and where all the different data tools. What I'll say here is there's like a zillion data tools on AWS, and we don't have time to go through all of them, but I will mention that a lot of the stuff that's in here, like Data Zone and Lake Formation and some of these things, and Glue, these are things that are embedded now into that SageMaker Unified Studio capability, right? They kind of brought these things that people were using a lot into a more holistic experience. So you're not kind of going, oh, I need this, and then you got to run down the hallway to get it and figure out how to bolt it together. They figured out how to do that to make it a much more seamless problem-solving experience. So that's what I'll say about that. All right, back to this. I put this slide up again for a reason, which is I wanted to circle back to Bedrock. So Bedrock is kind of a slightly higher level thing than SageMaker. SageMaker is, writing code and figuring, well, Bedrock is too, but this is, I think, more about, I find that it's more on the inferencing side and RAG side and all of that kind of thing. How can I incorporate these large language models or multimodal language models or whatever into other applications or other data analysis, right? So again, there's a single API. So that means I can flip out the different models as I need them and be able to experiment with, cheaper and smaller, or bigger and slower, or fancier, or whatever that I need to be able to do, rather than everybody. Because believe me, they all have they're different enough that it would be a headache to go to each one and figure out how to do the APIs. Although with AI, maybe it could do it for you. But the point is that this is kind of one-stop shopping. Plus, you get the ability to the privacy part, which I at least think is worth it. Doesn't really cost any more than using the AIs directly, or the APIs directly from the providers. There's a ton of open source ones on there. Like for example, DeepSeek, right? DeepSeek came out, back in January or February, and everybody was like, going nuts. DeepSeek. It was on Bedrock, I think, within a week, right? So they don't waste any time getting these things on there. All the meta models are on there. There's commercial models on there. There's open source models. You can put your own models on here as well, by the way. So it's very flexible. You can customize the models, so you can take like Claude 3.7 and add your own stuff into it and kind of train on top of it. All kinds of stuff. It has built-in ability to do RAG. There's a functionality inside, which I think I have a slide on, and a bunch of other things. And I'm going to show you a demo of how easy it is. The demo I want to show you is how easy it is to use Bedrock. A lot of questions about what's the difference between SageMaker AI and Bedrock. So again, SageMaker AI is more on the, more about the models and building them and enhancing them and writing code and writing kernels, and a lot of that is how I would put it. Bedrock is more on the application side, which maybe, like I said, to me kind of fits more nicely. If I kind of split the AI world into people doing research and working with AI itself, building kernels, doing advancement in AI, they're kind of more on the SageMaker side. To me, this is just my opinion. And people who are domain scientists who want to incorporate AI, different AI modalities into their research itself, I think are more on the Bedrock side. That's my 10,000 foot view distinction between the two. It's not don't take that hard and fast, but if you're just trying to go, well, you have this and you have this, and when do I use which one, right? I still recommend checking out SageMaker AI and those jump starts, particularly if you're dipping your toes into this, because a lot of those tutorials will help disambiguate a lot of this terminology and what things are for and what they're good for and not good for. But I think at the end of the day, a lot of people end up on the Bedrock side.
Can I
Yes,
question?
please.
A lot of this discussion was about generative AI and LLMs, because a lot
Yep.
of scientists deal with roads.
That's right.
And we don't use LLMs always.
So we design our own models. So we view.
Then you would be on the SageMaker AI side. But what you can do is you can build a model and put it into Bedrock. Okay. What Bedrock is kind of a serverless model server, right? Where you don't have to do all the infrastructure to host the model and do inference on it, right? Or other things. That's the way to think about it. You don't worry about the infrastructure at all on Bedrock. Okay. SageMaker, you can pick resources to use if you want. It's usually around cost and time and all of that. If you've got a lot of money and you need it quickly, you can turn the knob up to 11 and away you go. If you're, have a more human budget, you could use something smaller and it'll take a little longer, or you got to have a smaller problem, right? But if you're doing your own models, right, you would do that primarily, I think, on SageMaker. I will say that there are ways to take these big models and enhance them and train them, refine them in Bedrock also, right? That's easier to do. Not all the models I think are available in SageMaker. I don't think you can get the Anthropic models on SageMaker, can you? Yeah, so there's some that are not there. Now I'm going to show you an example of a kind of a science application that I whipped up very quickly that uses its own RAG system outside of that. But I'm using the large language model in Bedrock, but then I have an external RAG system that's with my actual data, right, to make sure that I'm getting a real information, not kind of imagining stuff, right? But if you want to do RAG, there's a RAG that's built into Bedrock. Again, if you don't want to know or don't know how to set up, do embeddings and the vector databases and all of that, you don't want to worry about any of that. You can do it right inside of Bedrock itself. So again, this is kind of how much of this do you want to get dirty with, and how much do you want to just sort of hand over to, an environment that's pretty easy to use. And even in this, I think you can pick different, vector databases like Pinecone and a few others, right? Yeah. So it's using all the things or many of the things you would be used to using. Agents, I'm not going to spend time on this because you're going to talk about it, which is a whole new area that's very exciting. And that's the end of that. But I want to show you a couple things, and then I'm going to stop. So the first thing, I need my glasses. The first thing I need is my glasses. So there's two things I wanted to show you. So the first one is I was thinking about, so I was curious how hard it would be to write just a chatbot using Bedrock, right? Kind of a simple first, like, hello world project, right? Because mostly I was using my own Llama or whatever on my Mac here and just doing it that way, doing every little piece myself. And, frankly, that was fun and I learned a lot, but it was not, it took a lot of resources. What is it? Amazon, there we go, activate. And, I'm like, all right, let's see if what everything Scott just said it make things easier. So I wrote a little program that's called Bedrock Chatbot. Not that exciting, Python program. This is less than 100 lines of code. Most of it is comments, right? And I put this on GitHub, so if later you want to look up Scott Friedman and whatever, you can download it and look at it yourself. But I'm just going to run it here real fast. I'm going to say Python Bedrock Chatbot. That's all I should have to do. And I can pick what model I want to use. The Nova models are Amazon's new models. They just came out. They're, allegedly really good. The one I've tested them, and they are, Nova Pro is, I think, close to Claude. My favorite is Claude. But I'm just going to pick Nova Micro. And then I get a little prompt, right? And I'm going to just say, tell me about the University of Washington. Boop, right? And off it goes. Boom. Now, I don't have any model on my laptop. I just talked to the model on Bedrock, and it did all of the magic, right? And then I get a response back. So really, a lot of this 100 lines is about what, setting up the API and all this other kind of stuff, right? Which is really kind of boilerplate. Now, chatbots are kind of passé at this point, but the point I wanted to make with this is that it's just a handful of lines of Python code. So if you're a Pythonista, or frankly anything else, because there's libraries for AWS for most languages now, Go and a bunch of others, JavaScript. This is totally tractable thing to do. I mean, I wrote this and I'm a computer science nerd, so I'm asterisking what I'm saying. I did this in about 2 hours. Okay, so starting with not knowing how to use Bedrock at all. And now you can steal this code and take advantage of my 2 hours and do whatever you want with it. But the point is that doing this is pretty simple. Now I thought, okay, that's sort of interesting. Let's try something else, a little more fun. Although I think this is pretty fun. I said, let's do an actual application. So I'm going to clear this so it's at the top. Can you guys see this? I'm going to make this bigger. Is that better? You see it better now? Sorry. So I wrote another program, and you will be amused that I actually wrote the core of this using the chatbot I just showed you. I said, I used Claude, and I said, I want to write a little program that allows me a RAG-based application that pulls some weather data down from the open registry on AWS. So this is netcdf files, if those of you knows what those are. Build the embeddings for it so I can ask questions about this data set, right? So like, let's say you have sensor network or stuff coming in, this is the kind of thing you could do with that, right? You could say, all right, I want to ask kind of general questions. So let me fire this up. Let's see, that's that. I'm trying to find here, Python, weather, not that. I forget there's a command I need here. Whoops. Oh, what's going on? Oh, I'm in the wrong virtual environment. Sorry. There we go. What is it? Disable? What is it get out of a virtual? Why am my brain is locking up? Kai.
Deactivate.
What? Oh, deactivate. Thank you. Thank you, sir. When you're standing up here, your brain is going in eight directions at once. Activate. Okay, that should be better. I want to use all records. Now I have it defaulting to, so the first thing it's going to do here, and I actually have another little program that you saw snap by, is I actually check which models are available to me and have been enabled and in what region and a bunch of other AWS-y stuff. And then immediately it starts loading the data. So it's loading, it's actually loading it to my laptop because it's a little Python actually it's not my laptop, this is running at home, on my Mac Mini 4 at home. So it's pulling in, this data is configured daily, so it's daily weather precipitation data from around the world for, I think that defaults to 2022. Why 2022? I don't know, that's just what I picked. You can change the year if you want. So it should load in all of these dates, hopefully, or did earlier. And come on. There we go. And when it's done, you'll have to look near the bottom of the screen there. You may have a hard time seeing it. It will create the embeddings, right? And then we'll be able to ask some questions about the data. Now, I did not clean this data or anything, right? This is just the raw data from NOAA, okay? So where are we at? We're at, we're at June. So we have a couple minutes here. Now this, question?
Yeah,
Go ahead. Yeah.
So if I wanted to do like a notebook for fine-tuning LLM,
Yep.
but I want to have control over the GPU that is connected, am I looking at SageMaker to do
Yeah.
that?
Yep. Yes. So you don't have control over the hardware on Bedrock,
Okay.
right? It's like, not. It's just like if you used Claude or, OpenAI or whatever, right? You just use it, and how they do it is black box, right? But if you want to like decide what the throughput is and all the token stuff and all of that, you would use SageMaker or I think even in Bedrock you can get into, you can dial it, but not the hardware itself.
And you can do provisioned throughput.
Yeah, right. So like companies that are building like commercial products on top of Bedrock, right? They have throughput requirements that are really, so what they did, for example, with Claude, you have to get what's called, well, it's not provision throughput, you can do that, but there's like a special inferencing setup. But like people can say, I want to provision a certain amount of input or throughput. So that like guarantees that you're going to get that much oomph. But like if you were like, I want to try it in this kind of GPU or that kind of GPU, that's SageMaker.
Oh,
okay. Yeah. All right. So it's busy generating the embeddings. Question? Oh, I'm sorry.
Yeah.
Oh,
Yeah, I just had a question regarding the Spot instances.
yes.
So usually I work with Kayak and it works on like a Slurm scheduler for
Yes.
SaaS jobs.
That's right.
I was wondering, how is this Spot scheduling any different from that? And in which instance should I use this versus Spot instances?
Well, I need you to clarify the second part, but the first part is, it's a little different in the sense that Slurm is scheduling across a fixed set of resources, right? And you're maybe describing the resource you want, and it's looking for a slot and then at some point in the future, asynchronously, it will run your job. In Spot, really all you're doing is you're using the hardware we're not using, or nobody else is paying full boat for. So it's still on demand, right? Yes, so you get it now. But if there isn't, let's say you ask for a very specific thing and there isn't any of those available, you will get an error, right? Because it goes, the super pink one with flames on the side is not available right now, sorry, and you'll get an error back. If it is available, you'll get it. So in the scheduling sense, there is no waiting. Now, there is one asterisk to that. If you want sort of the latest, Buck King just crash? Oh, I'm sorry. Well, what are you going to do? If you want the latest, oh no, actually, let's see. I'll see if it works. If you want the latest GPU, those are under such heavy demand. We are what are called capacity blocks, and you have to register ahead of time. And then you would say, there's like a calendar even. You could say, I want it, there'll be a green day, and that's like a day you could grab one or whatever you're looking for. And then what you'll do is you'll get a reservation, you'll get a code. And on that day, when you launch it, you give it that code, and it's kind of like when you're buying tickets to a concert and you get the code and it lets you in early, it's kind of like that. So, but that's not really scheduling either. That's just telling you when we're gonna hold it back for you. That was why we're talking about implementing bursting on HIAC, because in Slurm, you could, if let's say the bursting was implemented on HIAC and you wanted to burst into AWS to run in the future, like a capacity block, Slurm has the ability to say, run this job on April 17th at a certain time. And because you're bursting and there is no queue waiting in the cloud, you could just say, and then it would hold it until that time and run it. Does that make sense? That would be the easy way to do it. There are cloud native ways of doing it too, but a little more work. Okay. Any other questions?
Thank you.
I bummed my thing died on me. I could probably fix it, but I don't want to hold up Kai. Maybe on the side you can look at it. But that's what you get for letting AI write the program, right? What was interesting about this experience, though, writing this little weather thing I will share, is, and this is another reason why letting AWS just do this kind of thing as a service, is like this little program, because I was using Face, which is the embeddings vector part, I had to use like a Rust compiler, and I had a very specific version of Python I needed, and all this other stuff, and that took longer than like writing the program. And even then, it's still not working right. So the point is that I'm kind of making my own point by it not working, because the point is that this is just a big pain in the behind. And it's like, who needs that? I want to get back to my research, not dink around with this stuff, right? So anyway, I hope this was generally interesting. I think what Kai is going to talk about is going to be super interesting. And I appreciate your time, and hope you give AWS a spin sometime.
And
Yes,
Scott, there's a couple questions
Please.
in the Q&A.
Can you read them, Rob?
And then also, someone had asked if you could post the repo, the link to your repo.
Yes, we can share. I'll give it to you. Okay. But anybody who's listening who's curious about the repo, it's actually there already. And if you fix any bugs, send them to me. So you can look up my name. You can look up my name, Scott Friedman, Friedman, and GitHub, and you should see my picture. And that's the easiest way to find it. And it's a public repo. So
as the current administration is shutting down contracts with cloud providers, will large data sets from NOAA, USGS, et cetera, remain on AWS open?
As far as I know, they're going to stay there. Now, unless they yank them down. There was, to this specific point, there was a big discussion internally of certain data sets, people were copying them off of the Open Data Registry. But as far as I know, the company has no intention of deleting anything. Right? But if the owners of the data decide to wipe it off, well, that's... Well, we're not the owner of it, but we have no intention of preemptively removing it. Let's put it that way, right? I can't speak for how Amazon would react to the government or somebody in the government saying, get rid of it, right? I can't speak to what they would do. I would hope they would do what we would all hope they would do, but there were some discussion about some data sets from some NIH centers that are under major threat of actually some universities were copying that data down just in case, I will say. So
yeah, if anybody is interested in pursuing this further, just let me know, because we have a program here at UW that's related to this. The next question is the native Anthropic API available on Bedrock, for example, for clients that use Anthropic specific endpoints?
Well, the quick answer to that is the interaction with Anthropic is the same. The API is different, but the way that you interact with Anthropic, like the way you form the prompts and that stuff is the same.
Okay. And the last question here, also from Noah Hoffman, is can you share the GitHub repo?
Yeah, so just search on Google Scott, S-C-O-T-T, Friedman, F-R-I-E-D-M-A-N, and GitHub, and you should find me. And it's a public, it'll show up in my public repos. I have only like 10 of them, 10 public ones. So, and we'll send something out. I will give it to Jeff here, and we'll follow up. Okay. Any others, or is that it?
That's it for now.
I will share that I tip of the cap to AWS. When the Ukraine thing first started happening, we ingested almost all the data at all the universities in Ukraine into AWS to protect it. Libraries and universities. So that was this big effort with Globus, and I don't even know how much data we moved. I stopped counting after a while, but that data is still sitting on AWS at Amazon's dime. So occasionally we do the right thing. So now I'm going to turn it over to you. Thank you very much. I hope this has set the stage.
A 10-minute break.
So my name is Kai Dickman. I am a AI and machine learning specialist solutions architect. I actually live here in Seattle, so it's very cool to be here on campus. I didn't have the privilege to go to school here, but it's fun to see it. Ryan also is a solution architect assigned to University of Washington, so we're the people that are here to help you put together the Lego blocks. I really liked how Scott pointed that out. We're not a consumer tool necessarily. Like, how many people are using consumer grade Gen AI today? ChatGPT, okay? Yeah, most everybody these days, right? Using a chatbot to assist us in some way, shape, or form. Let's see, how do we advance here? So this is actually an older slide off of a previous machine learning deck back when we just had SageMaker. And great questions, and feel free to interrupt and ask as many questions as you like. It is nice to be interactive. I think we're going to pivot a little bit before we get into some of the slides. At 2:30, we're going to kick off a hands-on lab. How many people here in the chat and in person here are planning on doing the hands-on workshop? Okay, a fair number. Again, so we were going to start that at 2:30, so I think we'll probably jump to that pretty quick. Scott covered a lot of what I would have covered, and during the lab, it can be interactive. I'll be stepping through some of it on the screen, but also you guys can be heads down, but we can just make it, collaborative. So the interesting thing about working at Amazon/AWS is we're a work backwards culture. We like to think is one of our peculiar things. Over 80% of the services that you have within AWS itself comes from, customer feedback, right? It's even just like that 5-star thing on Amazon.com. What do you all need? So it'd be really interesting to hear your voices, kind of using this slide as a bit of that to engage on. Again, these are some traditional machine learning use cases, right? Fraud detection, user productivity, extract and analyze text. Those are very traditional type of models, right? But what all are you looking to do in your domains or your areas? Who wants to show and tell? Who has something to share with AWS, what you're looking for or trying to do or are doing? And also, I think probably your peers here would be interested to hear too.
Yeah, I think from the very beginning of my PhD, I've been training a lot of models on AWS.
Mm-hmm. Okay.
So now I'm using the term very frequently, almost every day.
Okay.
Then now I'm trying to go for fine tuning.
So really interesting story there. Somebody that was using SageMaker had actually trained their own models and then is now using Bedrock because just that undifferentiated heavy lifting, I would assume, because it's just real easy. You can just few lines of code query an LLM, right? Okay. We're using the Invoke Model API or the Converse API? Invoke Model. Okay. So one thing I was going to touch on from a more technical perspective, then we can get back to see if there's others that want to share their stories here, is that Bedrock has several, I think it's grown to 6 APIs. There used to be just an original one, besides the orchestration APIs. It's called Invoke Model. But there is a new API called Converse. The Converse API simplifies some things for you as a builder. The Invoke Model API is great, but what you'd notice if you've ever used it, different models take different input parameters. So again, Bedrock does make it easy to go access this whole fleet of different model providers and their various model sizes and whatnot, but you'd have to sort of tweak your API, your request, right? Your request parameters, you have to change it. It was kind of frustrating. So there is a new Converse API where you don't have to restructure those parameters that you pass in with your request. All you have to do is really swap out the model ID, if you may. Okay, and to get back to the timing, I never finished that topic, but maybe we'll just prattle up here for another 7 or 10 minutes, and then we'll just get into the lab. And again, we can keep the questions going. But great use case. You've seen both sides of it. SageMaker. Another comment on SageMaker. I like to think of it as a gas pedal for a bunch of ephemeral compute. So it goes to the gentleman here. You were talking about how can I schedule jobs and stuff, like with Spot and whatnot. It's like, yeah, maybe not the right mental model necessarily. It's SageMaker is about ephemeral compute. You need a bunch. You could schedule the time that you need a big block available, but otherwise download Boto 3, which is the AWS SDK. The Bedrock libraries are built into that, or I'm sorry, the SageMaker, actually SageMaker has its own SDK. It gets a little confusing in that point. But again, just with a few lines of code, you can spin up a bunch of ephemeral containers, run your training job. Maybe you want it to run longer if it's inference and whatnot, but just another good way to think about it. But who has other great use cases for what you're looking to do that they'd want to share with AI, machine learning? Don't want to share? That's okay. I'm shy and I don't like to be put on the spot too. I just get paid to stand up here.
Yeah, I guess I've been working on training a large vision model on grain scans from scratch.
Okay.
And the other things I guess I was curious about is currently we're doing it just on EC2 instances.
Yeah.
Because we can get spot prices on them.
Yep.
And then type point. And I was curious, I guess it seems like it could be nice to have some of the features SageMaker provides. It seems like the pricing and do spot instances. So
a spot, you should be able to configure spot with SageMaker. Yeah.
So then maybe I was,
yeah. Yeah, but that's exactly something that I'm here to help support with, after this, work with the account team here. Don't know where Jeff got to, but can help out with that. But fun project too. So you've got your training scripts, and what are you using for a model or algorithm for your?
It's based off Dino V2, but then we swapped out the vision transformer for something volumetric. So it's still transformer based, but it's the same as the
Okay, yeah, fantastic. Yeah, but that's where SageMaker, again, EC2 works. You're just having to do a lot of the wiring yourself. Yeah. And I think another thing too, to your point on the fine tuning, there are layers of abstraction really through the stack. If you want raw compute, run on EC2 straight up, you want full control, you can do that. You move up to SageMaker, it abstracts a fair bit, it takes care of the orchestration of all the containers for you, and actually it is just pure containers versus EC2 is more virtual instance style. But again, so you can fine tune through all those, and even within SageMaker, you can fine tune with Jumpstart, and then in Bedrock you can fine tune. You just lose the dials and knobs. So if you're deep in it, you're probably gonna be down in SageMaker or EC2. But you can always start fine tuning in Bedrock also. It's just a lot of people that are deep in it, especially from a research perspective, are like, no. Bedrock's great for just for inference, but the training, fine tuning, not as much. So, okay, so we've got some cool use cases. Others, one more. General curiosity. Okay. Anybody building basic chatbots just to support your work? No? Yep, I see some nods. Okay. And the reason I bring that up is that's the user, the employee productivity. Some of this is very commercial on some of our slides. I spend most of my time with state and local governments, and we're still, though, they were very 2024 chatbots. We still do a lot of chatbots. But the way I look at it, the way in how we work at AWS is everywhere I turn, I kind of expect there to be that Gen AI assistant. Is it my code assistant in VS Code? Maybe it's more of a general chatbot that's just really good at AWS. So we have some fine-tuned chatbots that are available internally. And it's unfortunately because I'm not calling my SA buddies as much like Ryan here to ask questions. I go to internal Gen AI chatbots, and it's really good to iterate, right? And the reason I was asking about the chatbot, because wherever you're working, it could be that you want to create your own very specific chatbot just for that ideation before you start to get deeper in, right? So there's that kind of general chatbot with some great ideas. So still, to me, a very strong use case. I'm not ready to see Gen AI here yet, okay, right? Maybe on the entertainment system in your car, but hopefully not the autonomous driving components. So let's see. So today's topic and the lab is going to be on agents. Is agents a new concept, existing concept? We have some pros over here, so I'm always looking over here at these guys. Is anybody building generative AI agents?
I have a question about agents.
Yeah.
So I have sort of two competing definitions in my mind. One of
Yeah.
them is an agent is sort of is a way of referring to an LLM that's got some kind of prompt engineering built into it.
Okay.
And then another definition I have is an agent is some composition of LLMs maybe that has access to things like an execution engine, so we can write code and run it, stuff like that.
Right, right.
Can you give us a picture of where the real accurate decimal posture?
Well, let's see. I do want to come back to that slide right here because I think that's worth double clicking on, but I'm going to keep going. I'm with Scott here. I don't like the dynamic slides. They're killing me already. We'll do it this way. This to me is what I'd call the definition of an agent. But I like that you brought that up because that really varies. And that's exactly where I would have started on this slide is how do you define an agent? And it's going to vary between the individual, between the AI practitioner, and often it's going to vary between the actual, what do you want to call it, the tool makers. You know, AWS, how does OpenAI define an agent, et cetera, et cetera. So to me, in my personal definition, would match to this. Okay, and this is just a copy paste, a cut and copy off of a website. It's giving an LLM capabilities to do something. It's giving an LLM the capabilities to interact with its environment. Because when you think about it, an LLM or foundation model, they can't do anything. You're going to give it data and you're going to get a response back out of it, but they actually can't take action. So to me, an agent is building some compute around an LLM so it can go do something. It's essentially that orchestration. So a more complete picture might be this is something that you could build with agents. So this is a diagram of a research agent here. You have an orchestrator, which is Crew AI. You've got multitudes of those out there, LangGraph, as well as Bedrock. So that's a key point also, is our Bedrock API also can do all the agent orchestration for you. So not a concise answer, Rob, because it depends who you're talking to, how to define it. But for myself, it's really this. Can you enable an LLM to go interact with this environment? And if you haven't, and we could define what that means too. You could use an agent to go call a small Python function, a tool as we call it, right? Just go do some basic math, a code interpreter. And actually we're gonna do, that's really the primary focus of what we're gonna do today in our lab. It could be a text to SQL query, right? So you use an LLM to generate that SQL statement for you, which is very cool, using natural language. Let's get a SQL statement out, and then but the LLM can't do anything with it. It's just going to say, oh, okay, I need to create the SQL statement. I'm going to create it, and then I'm going to hand it back to my program, and the program's going to go execute it. So to me, that's an agent example. Call an API versus downloading all the weather data like he did manually into a vector store. We could just query that API directly using a tool. So that's interacting with the environment. So that's where I'd go with that one. Just a couple things to really emphasize from what Scott was saying. I just like this one because this one comes up so often. Just worth going over it again. When you use Bedrock, when you use our models, whether it's a third-party model or a first-party model, and when I say first-party model, Amazon now has their own models. They're not AWS models, they're actually Amazon.com models. We just expose them through Bedrock on AWS. So Amazon is a very large customer of AWS, so even in that large language model and foundation model arena, same thing goes. But your data is safe. So a good way to think about it, AWS and working with our tools, it's enterprise grade, right? So security is, job zero at AWS. So you're going to have native security built in, enterprise logging and all that stuff. So it's a big tool. And it's actually created an interesting space where does AWS fit? OpenAI as that consumer product, everybody's using it a lot, but Where does AWS play in that sphere? Well, it's really for those that want to go build their own platform. So we do have some easy out-of-the-box stuff, but just wanted to highlight this. Don't share your data. It's always encrypted, in transit and at rest. Decrypted when it goes into the model, of course, but just good to know. And anything else I want to grab from a slide perspective? And any questions too. If there's other questions from the group, feel free to fire away. So for those of you that are not working a lot with models today, there's a lot of model choice. So actually, that's a good one to look at too. Let's do this. We're kind of going around, jumping around. A couple philosophies on how we're developing AI and machine learning at AWS. And again, everything's from the ground up, right? You need to build the foundations. You need to build the primitives. Actually, a good pop quiz is, what was the first service that AWS developed? Andy Jassy and his gazillion-dollar idea. What was our most primitive service? S3? Get this. What? S3? You're going to. Okay. What's that?
I said I know what it is.
Oh, okay. I could be wrong. So if you do know something else, I'll change my spiel.
It says 3 and simple queuing service.
Oh, simple queue service.
Yeah.
Okay. But S3 is the right answer for me, so yes.
I always heard SQS.
Really? But that actually makes sense.
S3 is whatever.
Okay, we're sticking with S3. I have some naysayers in the back, but they work with me. So.
10 million services.
But that's, again, it's building from the bottom up, building those primitives, making it a solid foundation, and that's part of why, enterprise grade. But choice, so there's not one model to rule them all, right? So we have our Amazon models, we have Anthropic, we have a whole suite of others. There's literally hundreds of models you can bring in, the customization, the fine tuning, integration. So, do you want to bring your model to your data or your data to the model, right? But we're very tightly coupled with S3, structural data, et cetera, and then security and governance, right? So that's actually another question I'd have for the group here. When you're talking about generative AI and even machine learning, is responsible AI and governance parts of the conversations and policy and controlling those things? Okay. So who dictates that for you? Is that for yourself as a researcher or a grad student, or is it the
Ever since I started my journey, my research has always been on responsible AI.
Mhm.
So it's like I pretty much decide how I want to define it. There are
Right.
millions of definitions.
Yep.
Yeah, but it's always I don't know how it works in companies, who enforces that.
Mhm.
But in our project, it's mostly advisor tries to see that we're not harming someone,
Mhm.
and our end product is not being unethical towards certain populations.
Yep. Okay. Like a higher body that approves.
Yeah, at university level.
Okay. Yeah.
Some humans are involved in that.
Okay. Yep. Cool. Okay. Yeah. So commercial entities is going to vary widely, but they're typically going to have some sort of policy. I work a lot with state and local governments. They've been very slow to adopt, though they've been chomping at the bit because policy takes a while within your government structure. So again, very interesting to hear that in the higher ed that a lot of it's defined by you, though there is some oversight. Okay. Yeah. Yes.
Yeah, question actually, in my domain sense, the reproducibility is more important because we deal with open data and we deal with people, so there's no ethics problem really.
Right.
So in the, by using all of these different LLMs that work together,
Yeah.
is this entire, if I ask one question in a own scope chatbot, would I get the same? Because I know with ChatGPT, I know there's factor up or reproducibility right? Because how is that going to be to get small counts?
Well, different models are going to give you different responses. So that's right there. So there's some variabilities, but fix that. Yeah, so if you fix that, so there's a couple things you can do is you can lower your temperature. So there's parameters that you can tweak, temperature, top P, top K. And then also some models will support seeding. So if you feed in a seed number, you really are going to get everything back, the same response back every time, as long as your input is exactly the same. Yeah, so it's, parameters and then as well as seeding, which I guess you could call a parameter as well that you can pass in, yeah. Okay, so we can talk about a couple of patterns and then we can get ourselves into a lab. So high level architecture for a research type Gen AI chatbot. Again, as chatbots are still how we do a lot of generative AI, but there are a lot of fantastic creative uses. And to me, that's actually, I don't consider myself a creative person, but those that excel at Gen AI are just super creative, right? Once you learn the tools and stuff like that, how can you snap all these things together? How can you get creative with your prompts? It's I don't want to say the sky's the limit, but beyond the chatbot, right? How can we use this to dissect large documents? I think as you're writing theses, yes.
So just like there's this protocol, like for some tools like the MCP, which I'm not even sure what MCP stands for, but is there like an emerging protocol? Because there are these services like Crew and a couple others, but is there kind of a protocol that people are working on for the agents to be able to talk to each other directly? Is that something that people are thinking about, or they always use these orchestrators? So it's kind of,
yeah.
Or is that what you typically, is that how like what you're going to show works? Or?
Yes, the orchestrators are what, and that's talking about how do we get these models to talk to each other, right? So there's going to be different frameworks for that orchestration, okay? And those are going to be programmatic calls, okay? More event driven. And then MCP, I do forget what MCP even stands for. Thank you. Thank you. Context, yeah. Are people using that to talk between models or just your plugins, your external data sources, the way I look at that? Okay.
Mostly just tools, executing tools, yeah.
Yeah, because that's what I think of it. So the discussion here is really what common protocols, languages, frameworks to actually do some of this coordination. And the way I think of MCP, and I've only had a little bit of time to play with it, is actually as a common language, a way construct for defining your tools or your plugins or whatever you want to bring to your agentic workflow. So to talk a little bit about the creativity component, you know, does that show up well? Maybe we'll go back to full screen real quick. So some of it comes down to how do we actually stitch these things together? So we have our agents, but how do we actually create our flows? And there's common patterns, and I was just going to flash a few on the screen. The prompt chaining is a very common way to do it. Okay, we're just going to logically pass through a flow of some sort, and again, that's where, say, a framework like LangGraph is very good at this. So we can have initial LLM call, we have a gate or a decision. Are we going to fail it, or are we going to go on and move down that chain? So it's kind of stitching those things together, moving through LLMs. Again, if your use of Gen AI is primarily in a chatbot type thing, just that one-off question and conversation, this is going beyond that. You can have multiple LLMs, so you can iterate and again apply to a problem in an iterative route. Again, you can parallelize it. You know, so if you need to do a whole bunch of processing, send it out a bunch of tasks, you can send shotgun those all out, bring those back into your application, aggregate it, and then you get your output. You can also use it as a router. So this will be, if time permits, we'll get to this. And I promise, even though we're going to be a little late getting to the lab, because I'm still prattling away up here, we've provisioned accounts for you, and those have a 72-hour lifetime, so minus 3 hours. So you'll have these accounts to work in, as well as the lab material to go home and run into the weekend if that's how you want to spend Saturday too. But it's I think they were nodding that that's definitely what they're doing this weekend. I got a doubtful look. So LLMs make great routers, right? So you can semantically route your traffic. You can route your requests. They can make the decisions for you. It gives them a high level of autonomy, okay? So you can use one LLM to make a decision. I need to go use this LLM and this tool. Let's send traffic that way. And to me, this is veritably the same pattern to use a supervisor. It's going to oversee work. It just might be a little bit more iterative. So again, this is the creative part. How do you stitch these things together? I didn't bring one in here. But you can have a whole network of agents, right? And to me, this is where I'm not talking to the big guns that are really working on AGI, AWS. But to me, how are you going to do AGI? Really, is going to be a network of LLMs, foundation models to really put this all together. It's not necessarily going to be this one massive model. It's going to be orchestrating a bunch of that. So getting down to agents, there's a lot that goes into an agent. And that's kind of why we see frameworks and stuff built around these, because it's not simple to do, okay? When we start to look at some of the components that go into it. So this goes down to, you know, as Scott was saying, what frameworks, how are we coordinating these things? We have our session, we have our memory. There's multiple types of memory, that short-term memory, the long-term memory. We have the actions we need to take. So not going to spend too much time here, but those are just the various components that go into it. And let's roll up the sleeves and get into a workshop. And I promise you this will be the hardest part of the workshop, is getting everybody in. And Rob, there might be people online doing it, or can somebody from our side watch the chat? We just need to be
I
able...
can't respond to the chat because it's...
Okay, so we can't respond to the chat. So it'll be what figure out how to support people that are remote.
But we can talk through your laptop if we see questions come.
Yeah, there you go. So I don't know if you're the one with the eyes on the chat, but if... Okay, good. Okay. So for people online, throw your questions, or if you get stuck into the chat bot. But what we're looking to do is go to that link. It should take you to a sign-in page. You do have to do a one-time password.
And it does take a couple minutes sometimes to get that email.
And is that link working? Okay.
So it was SQS went into beta before S3, which didn't have any kind of beta period.
So can I still say my S3 thing?
Yeah, because
okay.
S3 was GA before SQS was GA.
Okay. Because I can adapt.
Yeah, if we're going off the GA dates.
Okay.
You have got that though, so I've heard it both ways too.
Yeah, I never heard it. So we'll kind of go for thumbs up. Are people able to get by this? Okay, because I have some coaching screens to navigate through. You should come to eventually, once you get the OTP, get past that, come to a license agreement page. You're not signing away anything. Have people seen the email come through yet? Because sometimes it literally can take, okay, it's kind of moving fast today. All right. All right. And I need to get in there also. I did not really go deep into the models just because of time. But if you do want to try out, and you're going to have access to the Nova models in your accounts today, but you can also go to nova.amazon.com if you have a amazon.com login, like for your buying stuff. You can just go to nova.amazon.com and you can try out the Nova models at any time that you want. So kind of fun. And I'm just going to be flashing through some screens here because I need to get myself oriented as well. But when it's all said and done, you should come to a screen similar to this. Okay, on the left-hand side, we're going to have modules. I'm really targeting just module 1. It's going to be very basic, but it'll get you introduced to some of the concept around building agents and just Gen AI workloads in general. We'll do some guardrails. We'll do a basic, create a basic tool. But what we're looking for is down in the bottom left-hand corner under account access. That will actually drop us into our AWS account. People relatively caught up to here. People have got past the one-time password. Okay. No questions? Okay. So this is the fun part, is trying to do this on one screen, right? I'm just cleaning up a few things to not confuse myself. Okay, so the way I'm going to do it is I'm going to pull a tab out, and I'm going to walk through some of these things. But if you are one of those that just wants to race ahead, knock yourself out, go heads down, and start stepping through the lab itself, okay? There's some introductory topics that you can read through if you want. And actually, I think to Rob, your point, somewhere in here, somebody does define in this workshop their opinion of what an agent is. But the important part, I'm going to see if we can find that That's more about agentic workflows. But anyways, the first two sections here are really about just introductory material. But we do need to do some initial setup. And this is where I immediately prove to everybody Kai cannot follow linear instructions. So if you see me skip something or see me struggling, say, Kai, you probably missed step 2.c. Okay. But anyways, these are the workshop instructions. We do have to go through a little bit of setup, and then we're going to focus on module 1. But all this is available to you after the workshop. And as far as reference material goes for working with AWS, workshops.aws is an open website that has massive amounts of workshops for all of our services. And I often use those instead of the public documentation or the developer guides, because there's often just great examples in there. Okay, so it's a good resource. And then people were asking for Scott's repo for his project that he did. AWS samples in general has massive amounts of sample code in a variety of language for AWS in general. So of course, our generative AI, our Bedrock, our SageMaker, there's rafts of notebooks, rafts of Python example code out there. So almost too much, I think, was what Scott was saying. So I'm going to use, it's a bit of that flipping back and forth. So I do it this way to go between the console and my instructions. And I'm just going to start walking through. As long as everybody's caught up, nobody's blocked, everybody has an account, they found the way into the AWS account. Okay. Rob, we looking okay online? Sorry to call on you, but you're our,
No, that's fine.
our chat moderator.
We're okay.
We're okay. All right. Oh, fun little thumbs up bubble down there. We got more thumbs up. I dig it. I don't use Zoom a lot. It's got some cool features. Our internal chat tool at AWS, we call it Chime. You can actually go subscribe to it. It's one of the most primitive things ever. We do use Slack now, but as far as like the cool stuff you can do in chats. Okay, so let's see. We have our account. Okay, there's a little instructions for how to get into our account. First time into AWS for many people? Okay. AWS is a vast place. There's over 200 plus services. And I was going to make another plug for some of those more traditional AI models. Today we're talking about generative AI. Some people are doing some really cool, vision training and SageMaker and stuff like that. But there are also a bunch of other, especially around the NLP or natural language processing. If you have a whole bunch of documents you need to go parse or pull the text out of or something like that, you can use Gen AI, but we also have some really cheap pre-trained models, entity recognition and stuff like that. So those are other services you can find in here as well as your computer, whatnot. But again, you're going to have these accounts for 72 hours or 69 hours, so you can spend time in here just playing and learning. So, but that's the default view into AWS.
I have many other accounts, so it got confused with the account.
With our account?
Yes.
Yeah. So
How do I return to your account?
probably also a private browser would probably be good. And if you go back to the URL, which we can flip over to.
That was, I think, sufficient.
Okay. Okay. So. First thing we need to do is we need to go into Bedrock. And again, I'm going to be up here talking and distracting you all and trying to be linear. Hopefully you guys can be linear and work through these more successfully than me. But the first thing we actually need to do is we need to go into Bedrock and enable our model access. So I'm going to use the search bar at the top, kind of just like your web browser search bar, but use the one within the console. I'm going to type in Bedrock. And down at the very bottom left, we're going to do model access. Now the instructions are going to tell you to enable some very specific models. And one note, there's no charge to enable models. So if you have your own personal account or if you have an account vended from the university here, there's no cost to enabling models, okay? But you do. But the reason you have to do this is essentially there's EULAs behind these, end user license agreements, and that's what you're accepting. It could be that some models aren't allowed if you use vended accounts. Also, you could have service control policies or something like that from those higher up the IT chain there that are controlling this. I'm going to cheat, and I'm just going to say enable all models, and say next. Now, it is going to fire back a bunch of errors because not all models are available. So that's actually a good point. In these workshop accounts, not all models are available. But Let's see what we get back here. Submit. So it's going to error out on some, but it's just a quicker way versus going through and individually enabling models. I'm just going to go this route. Yeah, so I think in the instructions, just choose all the Amazon, the Anthropic, some Meta, Mistral, but again, I just went for the whole shebang. And we'll click next. And the Bedrock API. And that's what's fun today, and that's why I actually like this lab. It's very basic what we're going to build, but it also uses QDeveloper. Who's using Code Assistants in VS Code or whatever you're using? Give one hand. Okay. Yep. So QDeveloper is our Code Assist plugin. There is a free version, so if you're doing work on AWS, just go ahead and get it, even if you have one that you prefer. The QDeveloper is currently at the top of the charts as far as a good one to use. I'm not a developer. I'm actually a systems engineer background. About 2 years ago, I was actually an IoT specialist SA, but there's so much demand for Gen AI, I've been repurposed. So any of you that want to go real deep in models, you can stump the chump really quick. But I can tell you how to run stuff on AWS, more from like a ML engineering perspective. Okay, so let's see. We are running this at an AWS event, so I'm just going to check to see. Okay, so these instructions that we come up with next are to actually get access to our VS Code environment. So we're going to use a web version of VS Code within our environment, and it's going to have the QDeveloper plugin in it. So that's where the point I was getting to was the QDeveloper is where I was going, saying I'm more of a systems engineer, but I can now pretend I'm a developer because it cranks out so much code for me. It just makes it a heck of a lot faster. And I think if you're feeling stubborn about not using and you don't want to use a code assistant, get over that. It's going to make your life so much easier and productive. But I don't think I detect a lot of resistance to it here. So what we need to do is we need to go back to our outputs from the event, and it's going to give you a URL with a code to get into VS Code. I'm already logged into mine. Yeah, it's in the outputs. You'll have an output section when you first logged in. I think I might have lost my screen, but let's go back to the main screen we came to. Is going to have output section down at the bottom. So when you first came into the workshop after accepting the agreement.
Can you go up from there to the workshop part right there? You see that Get Started button on the right?
Mm-hmm.
Do I need to go through that?
I don't know. I've never clicked that button. So I think, so not required.
Don't touch that. You never know what
Yeah. Yeah. Nope, you shouldn't need to click that. You can just go right into the AWS console. I think with the Get Started, let's be bold. Yeah, it just takes us to the first. I'm not going to blow up, don't worry. That's my description's optional, but just not to miss a step. So Claude Sonnet 3.5 V2, it's a very strong, higher mid-range model from Anthropic. And we do have to give our agents instructions. We have to say, hey, what are you good at? What can you do? Kind of a system prompt. And if we enable the code interpreter is essentially a very basic Python library for interacting with CSV type data and writing basic code snippets. So we're going to add that in, give this a little bit of structure. We're going to skip the other things for the moment, and we are going to enable memory. Where's my memory? Let's enable memory. Okay. So it will store information for us, because if you don't do that, so that's again part of what Bedrock Agents is doing for you, is so you don't have to build all these things yourself, which you can do just with your own code or other third-party libraries. And also a note on that, Llama Index, LangChain, LangGraph, those all have AWS plugins and capabilities, methods within their API. So again, open source fully supports the Bedrock, and AWS contributes to a lot of that too. And just being released soon, if you use LangFuse or the Langstar suite, LangFuse is going to have Bedrock agents as well as invoke model metrics and observability built into it, which is really cool. Just heard about that today. So let's see. So we have a really basic agent, okay? And really all our agent's going to do at this point is call an LLM. So like to Rob's point, what makes an agent? I wouldn't say this is necessarily an agent, but at least we have the construct built. So let's see if I still need to save it. So when we create an agent, we need to save it. And there's a little prepare step, because essentially think of it as a runnable. We have a little bit of compute needs to be compiled because it's not just a call to an LLM. So it looks like our model, or rather our agent constructed well. And since we used the code interpreter, we can ask it, can you generate a bar graph? So let's see. And we are going to get a trace at the same time too. So we can actually see those thoughts. We can follow along with it. And there is our graph. We have a bar graph, okay? And if we wanted to, we could download it. We could show the trace. So we know it works here in the console. And again, the console is just a quick test bed. I wouldn't even call it a sandbox. It's just to come in and kick the tires, test some functionality. Everything that we're doing here, you could do programmatically. You know, you can define your agents programmatically from a notebook, however you want to do it. But the console is just a quick place to come and play around. If you don't want to mess around with agents, you just want to try some models, there is this chat text playground that you can also use. So that's a good place to be. How many people here have heard of Streamlit? Anybody using Streamlit? Okay, you are. A couple here. Yeah. So if you're not, it's a great little way, like once you kind of figure some stuff out on the console and you actually want to get a, webified or create a little app, Streamlit is great for doing those, especially on your local environments, doing some quick POC work and give yourself a real easy web UI. Or say you just, versus using Olama locally or something like that, you just want to run your own little personal chat bot and plug it into something. Streamlit, super cool, doesn't take a lot of expertise to do it. So part of what we get here with this workshop is a bootstrap on that. We do get a chatbot that we can run with Streamlit. I'm going a little bit off memory here, but what we're going to do is we're going to grab the agent ID is one parameter that we need to add to our script. So our agent ID is right here in the agent overview tab of what we just built, that most basic construct for an agent. So we're going to go into our agent tools.py. And we're going to replace our agent ID string on line 8. VS Code in the web, you don't have to worry about saving. It's going to do that for you, for better or worse. It's going to save it for you. And now that we have that, we can go ahead and instantiate our our agent. Sorry, I get disoriented where I'm at here in the instructions. Let's get rid of some of this. Which tab was it? Must have been this one. Okay. So we don't really have to build our Streamlit chatbot. Most of that was done for us. So again, went into the agent tools py file. It's a Python file. We put in our agent ID. We updated that. So now let's run it. And luckily, they have our command. So we're going to paste that into the terminal. And that should launch our Streamlit app. And you'll notice once you launch the Streamlit app, it'll give you a local URL you can use, and also VS Code smart enough to say open in browser. So there we go. So that last question that we asked, and as soon as I'm done with this, I'm going to check on that account there for you too. Not fair that you can't be playing along. So now we can ask that same question, but this time we're going to be able to do it in our Streamlit app. And we should get a response. And this gives a lot better representation of the trace. So when you think about it, when you get responses back from the agent API, is going to, part of those responses back are going to be the trace in that JSON response. It's not just going to be the model invocation. You're going to get your latency, you're going to get your token counts, as well as an actual trace. So it's nice the way that they built this little UI with Streamlit is we're going to actually get those traces back. So the first thing, and again, this is where we can actually see an agent in action. It doesn't have its own, well, I guess the code interpreter, we did give it a tool, but you might go through this trace and you're going to see, okay, so it's doing some reasoning here in this first rationale. That's like, okay, what do I need to do? Let's think about this. Okay, we have a plan. It's going to go to the code interpreter, and it's going to take a first crack at getting some code for us. This is what came out of that code interpreter. This is an LLM. It's going to get an observation. It's going to say, failed, okay, that error. So this is where it's going to iterate, right? It's going to iterate through until we finally get a successful output. So in the final response, but it says it just did it, right? There's no, we actually don't see the graph yet because our Streamlit app doesn't know how to pick up the chart. But per the responses, it feels like it was successful. And again, you could, okay, who's done exercise 3 successfully? Yep, people move through it, okay. Because I can pick back up with the follow along. I just kind of want to get to where the average team is at. So kind of cool. You can use the dev command in Amazon Q Developer. If you want to do security reviews, common CVEs, you can do /security. It'll understand the full context of your workspace. So if we go down to Q Developer, we can say /review. Sorry, I thought it was /security. It will review our entire code base for common CVEs. So it can yeah, thanks for coming in.
He's still getting the Cloudflare error even when he's even with the new account.
Okay. Rain check. Yeah. Money back. Talk to Jeff. Yeah, at some point. I just don't know. But it fixed it up front here.
Was it the Cloudflare, the 502 Cloudflare
yeah.
error also?
Yeah.
Yeah, because we created a new account off my email address.
And the same thing? Other than just keep going through them, because it could be an issue with the account creation. Sometimes that happens, right? So you could go for 3 times the charm.
Yeah, we could.
1/3 times the charm, just
one more time.
Because sometimes when accounts provision, they do fail.
Yeah,
Really, have fun in your account. Get through the instructions. I don't think we've quite made it through module 1 because I was going to say we kind of fell off the tracks in a variety of ways, but that's just the way it rolls. Good questions from a fellow here just on guardrails and a bit of how they operate. A bit of choosing a model for your use case is, we call it alignment. You know, how well aligned is a model, and basically how well behaved is a model. Anthropic trains their models with constitutional AI, so they're just trying to limit how much harm can come from out of one of their models. Whereas DeepSeek, you can ask it, how do I make fentanyl? It's going to tell you. Literally ran into that with a police department the other week. They want to use generative AI, but their offices are trying to have these hard conversations, and using well-behaved Claude models just not working. You know, they need to talk about more uncomfortable topics. So to the point of guardrails, some models are essentially going to have guardrails built into them, right? And you'll even find that if you interact with I'll hold on that. So again, I call it model alignment. There's different ways to talk about it. Some models are more responsible than others. Again, just that inherent knowledge that a model might have is just going to be well behaved. It's going to self-guardrail, self-protect. Otherwise, you can put constructs in the front of a request or in front of the model as well as on the output of a model. So you can put your guardrail on the actual user or whatever that input is. You can apply filters, guardrails, semantic topics. Guardrails is built into Bedrock with a capital G. It's like guardrails as a feature or a service or capability. But there's other ones out there too. LlamaGuard from Meta. Nemo is NVIDIA's, I don't even know what you call it, Gen AI framework, has a guardrail component to it also. But the construct I'm really getting at is you can put the guardrail on the input as well as the output, right? So maybe you're afraid you're using DeepSeek and you don't want it to spit out some PII and get you in trouble. So that's a good reason to put a PII guardrail on the outputs from the actual models themselves too. So again, why there's not one model to rule them all. It's you need choice, you need selection. It's not just the reasoning or chain of thought, or is it really good at code? It's like, what's it going to be willing to talk about too? So it's just a good little conversation we had in the back corner. Other comments or thoughts or questions? Was the pizza good? Who bought the pizza? Jeff? You didn't? All right. That one's on Jeff. The accounts are on me. Any other just AI or machine learning questions or thoughts?
So can you add your own models? You get an LLM?
Yeah, you're talking about just like a KNN DB scan type of thing, or like just train your own models? Yes. But typically I'd think of a model like that you're going to host in SageMaker with a SageMaker endpoint. So SageMaker is for model training and for model inference, okay? Yes. So if you train your PyTorch model in SageMaker, so you've got your training scripts and all that stuff, or maybe you even trained it on your local machine, wherever you trained that, right? So you've got your model weights, so we can bring that into SageMaker and then actually host that model, right? So that creates an endpoint that you can just call to invoke your inference out of. So then you want to use an LLM to call that model? Yes. Okay, yeah. So we would have to build an agent that understands what's over there, yes, and how to query it too. There might be you might need to give it an API schema or something like that, or define that function. So yes, so your LLM could decide, I need to call this PyTorch model over here. So then it's going to invoke that via a function of some sort, like one of those Lambda functions that were predefined for us here in the workshop. So then you would that function would then call the SageMaker endpoint. Yeah. So the way I would look at that other model, that PyTorch model, is as another API. It's just where is it being served from. So SageMaker can serve, and it does serve millions of models every day, right? So you just have to get your model into SageMaker. Okay. Yeah. And various ways to do that.
So is it possible that the agent cannot converge into a final answer, just thinking forever?
Sure, a loop? Yeah, you absolutely could hit a loop. Yeah. Have you guys ever hit loops? Or you're not really doing agents, or do you build agents? Yeah. How do you keep?
Stuck in a loop.
Yeah, which could get very costly. At least on AWS, depending on the model you're using, because that's another good thing too. Just another pricing construct. Most of your fees coming from Bedrock are token based. So it's tokens in, tokens out. Yeah. But I don't know how you break it out of a loop if it got in there. You just have to be aware of it in some, like too long running, I guess. Yeah. If it runs more than 15 seconds, just dink. Yeah, kill it. Yeah.
Back off and a threshold to break it.
Yeah, okay. Yeah.
Also, these agents are generally very slow compared
to
large language models. So do you have any solutions or thoughts about that?
Yeah. Limit your calls as much as possible. So if you find yourself with a prompt and a particular reasoning model that has to do a whole bunch of iterations, can you fix that, right? Using multi-agent orchestration or a supervisor agent, that can be slow too, because you're waiting for that first smart reasoning model to make a decision, 2, 3, 5, 8 seconds, and then it's going to make another LLM call, and now you're waiting for that one. Yeah. And I've just, not to knock our own service, I have heard that there can be latency challenges with Amazon Bedrock agents, especially in multi-collaboration. My point there is, look at your framework you're using. Is LangGraph going to be a little bit faster the way it puts it together? So it's how many invocations are you ending up with? Use your traces. LangFuse or Bedrock gives you traces, and that's going to help you diagnose. Model selection, some models are going to be faster. I'm just thinking of the various dimensions. Your prompt size, your context size. So it kind of comes down to snipping down all the various little, where can you optimize? It's not necessarily going to be one spot. What did you implement? Yeah. So very common. I think for myself, it's, again, I'm throwing stuff at Gen AI all day long, just in various chatbots, getting answers, iterating. I've just gotten used to, and I'll go switch over to another tab. And that's a struggle deal for some end users. They want it. They want their Google search speeds. Yeah. I think we're going to learn to, at least right now, it's going to take a little bit of time. Yeah. But there's kind of like a triangle or a triad. You have cost, latency, accuracy. And you can kind of pull at all those and get different things too. So that's that optimization. Cost, latency, accuracy. Yeah. But the trace is your key. You need a trace. Whereas it taking LangFuse, very powerful, very good for tracing. So you can actually see where am I incurring my I would like to say milliseconds. Where am I incurring my seconds? Another common functionality for your RAG-based architectures. So RAG is retrieval augmented generation. The first component there is the R, that's the retrieval, is using vector stores. So Bedrock has that built into it natively. Again, trying to do some of that undifferentiated heavy lifting. You can certainly stand up your own vector store, or Scott, who's taken off, he did an in-memory vector store essentially so that you can retrieve it. But the basic functionality that a vector store is going to give you if you don't play in that space is it's going to take your text or whatever, it's going to convert it into a bunch of numbers, right? It's going to do that embedding, and then it's going to put that into a database or to a data store of some part that can be actually searched for those vectors, right? So we have our vector engine. So that's been around for a while, right? But it's really become a thing with generative AI and those RAG type solutions. So native to Bedrock is the knowledge-based functionality, but really it's just a simplified manner to create your own vector store. And again, behind the scenes, that could be OpenSearch / Elasticsearch. You can use Pinecone, PG Vector, fast, cheap way to do it also. So again, just trying to make it easy to get that done. And also make it very easy to snap into your code. And the cool thing with it is anybody here playing with vector stores? Or spending any time on that? A little bit? Yeah, okay. So it's just a simplified way to implement if you want. Very effective. And then you just have a simple API call. So if you have a vector store, and if you're using Bedrock, you can make one API call, and you can get the retrieve and the generation of your response. That API is actually called retrieve and generate. And then if you only just want to retrieve the chunks out of there too, then there is a retrieve API that you can do, and you can sort of define some of your parameters for that, how many chunks you want to retrieve, chunk size, all that good stuff. So again, I'm just kind of queuing off some of the things here is, what's a knowledge base about? How does that work? We've gone through the agent. If you are going to run with this over the next few days or whatnot, there is a lab in here that does go over. It's got a Crew AI example. Unfortunately, it doesn't have LangGraph in here yet, but there is a LangChain example. So you can actually see what it looks like to stitch some of this together with those other frameworks and not just the Bedrock SDK. Because you'll find more functionality there, in my opinion, with some of those open source tools. But we're very much open source camp here at AWS.